Hello dear viewers, today I am going to talk to you about how to preserve meat by irradiation. Irradiation is well recognized cost effective method of preservation of meat and meat products. The safety of irradiated foods was demonstrated with experimentation. In the year 1980, the Joint Expert Committee of Food and Agricultural Organization, International Atomic Energy Agency and World Health Organization on the wholesomeness of irradiated food concluded that irradiation of any food commodity up to an overall dosage of 10 kg causes no toxicological hazard. Toxicological testing of so irradiated food is not required and irradiation up to 10 kg causes no special microbiological or nutritional problems. This has encouraged the use of irradiation method in meat industry all over the world. Irradiation is a cold process or cold pasteurization process. It destroys microbes without substantial increase in the temperature of food. It does not cause significant physical and chemical changes in food. When food is irradiated to an absorbed dose of 10 kg, the product temperature may rise only by 2.5 degrees Celsius. Hence, the irradiation technology is considered non-thermal. Radiation at low energy level does not induce radioactivity in food constituents. It will not produce any harmful toxic residues in food and can be used to treat pre-packed commodities. Irradiation achieves disinfestations of insects, enzyme inhibition and destruction of spoilage and pathogenic microbes and parasites of hazardous nature. The following aspects are dealt with in this topic: the sources of ionizing radiations, mechanism of action of radiations, irradiation processes, irradiation in combination with other treatments and quality of irradiated meat. Let us know about sources of ionizing radiations. Irradiation is the controlled application of energy from ionizing radiations. A joint FAO, IAEA and WHO expert committee of irradiated foods approved the use of only the following types of ionizing radiation for food irradiation: gamma rays from nucleotides, that is cobalt 60 with a maximum energy of 1.17 to 1.3 mega electron volt, or cesium 137 with a maximum energy of 0.67 mega electron volt, or X-rays generated by machines operated at or below an energy level of 5 to 7.5 mega electron volt. Third one is electrons produced commercially by machine sources at or below an energy level of 10 mega electron volt. Units of radiation. Radiation energy is measured in terms of rods, where one rod is equal to 100 ergs of energy absorbed in 1 gram matter. 1 electron volt is equal to 1.6 into 10 to the power minus 12 erg. 1 erg is equal to 10 to the power minus 7 joule, and 1 joule is equal to 10 to the power of 7 erg or 10 mega erg. A new standard irradiation unit is known as gray. 1 gray is equal to 100 rods, or 1 kilorod is equal to 1000 rods, or 1 mega rod is equal to 10 lakh rods, or 1 kilo gray is equal to 1 lakh rods. Now, let us know the mechanism of action of radiations. When ionizing radiations of approved energy levels pass through foods, there are collisions between ionizing radiations and food particles at the molecular levels. Ion pair is produced when the energy from these collision is sufficient to dislodge an electron from an atomic orbit. Molecular changes occur when Collisions provide sufficient energy to break chemical bonds between atoms and form free radicals. Irradiation of food helps formation of ion pairs, free radicals, reaction of free radicals with other molecules and recombination of free radicals. These mechanisms alter microorganisms and food constituents affecting food preservation. Resistance of microorganisms. The most radiation resistant microorganism in foods is Clostridium botulinum. Acid values below pH 4.5, aerobic conditions, extreme dryness in foods and or refrigeration below 4 degrees Celsius prevent growth and toxin formation by this organism. In foods where these conditions do not exist, the food is irradiated with dosage sufficient to destroy this organism. Food with pH above 4.5, Clostridium botulinum is not a problem, but other spoilage organisms must be inactivated with lower radiation dosages. Bacterial spores are more resistant to the germicidal action of ionizing radiations than are the vegetative cells. Resistance of enzymes. Most enzymes are more resistant to ionizing radiations than even the spores of Clostridium botulinum. Inactivation of enzymes requires very high doses of the order of 200 kg. Such a high dosage destroys food constituents and impairs safety of food. For these reasons, irradiation alone is not suitable for food stability. Hence, combination of processes is preferred. Enzymes are more easily inactivated by heat and by certain chemicals. Now, let us know about different methods of irradiation processes. Different materials absorb radiation energy to different degrees. The dose of energy absorbed is important in food preservation. A rod of radiation dosage represents the same amount of absorbed energy whether it comes from gamma rays or beta particles or a mixture of the two. Absorption of rods is determined by length of time the food is exposed to irradiation and absorption properties of food and its container. There are three different applications and dose categories when foods are treated with ionizing radiation. They are radiorization, radicidation and radioapertization and briefly described below. Radiorization. Low doses up to 1 kg are employed in this process. These low doses substantially reduce the pathogenic and spoilage microorganisms and enhance the keeping quality of meat and meat products. Radiorization is used along with refrigeration to maintain quality. The shelf life of fresh meats in refrigeration at 2 to 4 degrees Celsius is normally 3 days. The shelf life of radiorized fresh meats is 5 weeks at the same temperature. Radiorization is helpful if fresh meat is to be transported in a chilled condition to the destination. Radiorization reduces the levels of potential pathogens such as Salmonella species and spoilage organisms such as Pseudomonas species. Also, it causes insect disinfestations and parasite inactivation. However, radiorization may induce oxidation of myoglobin to metmyoglobin and drip from cut surfaces. This may cause off flavors in meat. Addition of sodium tripolyphosphate, use of oxygen permeable and moisture impermeable plastic wrapping with a dosage of about 1 kg prolongs the storage life of meats up to 3 weeks. The dosage up to 1 kg does not induce lipid oxidation. Radicidation. This process involves The application of medium radiation doses of 1 to 10 kg necessary to reduce the number of viable and non-sporing pathogenic and spoilage organisms. Meat and poultry are frequently contaminated with pathogens such as Salmonella, Campylobacter and Listeria, which are inactivated by dosage of irradiation. Radiapertization, it is also called as cold sterilization. Radiapertization is an alternative to commercial preservation by thermal sterilization, freezing and drying. The doses used are high in the range of 10 to 45 kg. It is similar to thermal processing of canned meat products. Reduction in numbers of microorganisms will be to the point of commercial sterility. Very few microorganisms survive following the radiapertization process. The product is shelf-stable, long-term storage without refrigeration. Products subjected to radiapertization should be packed properly to prevent microbial recontamination and the deleterious effects from light, oxygen and moisture. Both metal containers and flexible packages are used under vacuum to prevent rancidity of lipids. In India, irradiation process has been approved for treatment of meat, fish and poultry and their products. Changes occur in microbial counts, physicochemical and rancidity parameters. Immediately after irradiation of goat meat mince with a dosage of 4 kg gray, microbial counts are substantially lower in irradiated meat compared to non-irradiated meat. Enterococci, Escherichia coli and Staphylococcus aureus are not detected in irradiated meat. Water holding capacity and pH of goat meat mince are lower in irradiated meat. Changes in emulsion stability and hunter color values of meat due to irradiation are marginal. Irradiated goat meat has slightly higher free fatty acid value and substantially lower thiobarbituric acid value. Radiolytic products. The radiolytic products from all meats including poultry and fish are the same. They include several chemicals such as alkanes, alkenes, alkynes, aromatic hydrocarbons, alcohols, aldehydes, esters and sulfur compounds. Degree of formation of radiolytic components increase with dosage as well as with increased product temperature. Now, let us know about irradiation in combination with other treatments. As mentioned in many instances, irradiation alone may not be successful in providing safe meat. Combination of different treatments show better results for maintaining the quality of irradiated meat products. The combination treatments have synergistic antimicrobial effect. Incorporation of ascorbic acid and spice powders into meat products may offset the ill effects of irradiation by minimizing the production of off odors and flavors. Addition of alpha tocopherol or antioxidant into ground meat and proper packaging retards or limits lipid oxidation in the irradiated meat. The role of nitrite in meat curing is color fixation and imparting flavor to the product. Nitrite also inhibits the growth of Clostridium botulinum. The nitrite in cured meats forms nitrosamines that are carcinogenic, that is cancer causing. Radiation destroys Clostridium botulinum. Hence, nitrite requirement in meat curing can be reduced by 50% if the meat is subjected to radiation. Irradiation in combination with vacuum packaging, edible coating film containing natural antimicrobial compounds or modified atmosphere packaging reduced bacterial growth. irradiation and refrigeration of meat and meat products increased both safety and shelf life of products. High dosage of radiations required for inactivation of enzymes in meat or poultry products is detrimental. The dosage can be reduced by vacuum packaging in sub-freezing temperatures to prepare sterile shelf-stable products with excellent sensory properties. Such products have been used extensively by military organizations during space flights and hospitals. Quality of irradiated meat. Meat color is the primary quality attribute of fresh meat that affects consumer acceptance. Heme pigments, especially myoglobin, are responsible for meat color. Irradiation influences the release of iron from heme pigments and also converts oxygen to ozone. Ozone is a strong oxidizing agent and it oxidizes myoglobin. This causes bleaching discoloration. Pre-slaughter feeding of antioxidants to livestock or addition of antioxidants directly to the meat product helps maintain meat color during irradiation. Irradiated fats cause autoxidation in the late post irradiation period, leading to off odors or flavors due to increased rancidity. Peroxide value of irradiated meat may remain unchanged if meat is blanched and vacuum packed in cans or flexible pouches before irradiation. Proteins are built of amino acids. There are about 20 amino acids in food proteins, of which 9 are essential. These 9 amino acids must be provided in the diet since they are not synthesized by the human body. The nutritional quality of protein directly refers to its ability to provide 9 essential amino acids in the quantity required. Damage caused to proteins by irradiation includes deamination, decarboxylation, reduction of sulfur linkages and oxidation of sulfhydryl groups. Irradiation also causes breakage of peptide bonds and changes in valency states of the coordinated metal ions. Irradiation reduces water binding capacity of muscle proteins, resulting in increased drip loss. The solubility of collagen is increased by irradiation, which improves tenderness quality of meat. Irradiation decreases viscosity of liquid egg white, that is albumin, suggesting the denaturation of albumin proteins into smaller units. However, digestibility, biological value, net protein utilization and amino acid composition are same as untreated meat. This was depicted by experiments on rats. Changes in proteins due to irradiation of meat also influence the emulsion characteristics of proteins, which in turn affect sensory quality attributes of meat emulsion products. The vitamins such as thiamine, riboflavin and pyridine are reduced on irradiation, while niacin is not affected. Pantothenic acid and folacin vitamins are reasonably resistant to radiation. Carotene is sensitive to radiation, but can be protected by ascorbic acid. Let us conclude. Irradiation is a cold process or cold pasteurization process, as it can destroy microbes without substantial increase in the temperature of food. Irradiation is cost effective method of preservation. Radiation at low energy level does not induce radioactivity in the food constituents. It does not produce any harmful toxic substances in food and can be used to treat pre-packed commodities. Irradiation achieves disinfestation of insects, enzyme inhibition, destruction of microbes responsible for spoilage and elimination of pathogens, and parasites of hazardous nature. The radiation sensitivity of microbes is affected by the extrinsic environment including atmosphere, temperature and intrinsic characteristics such as pH and chemical composition of the product. Radiorization, radicidation and radioappartization are different irradiation processes depending on radiation dosages used to irradiate foods. Bacterial spores are more resistant to the germicidal action of ionizing radiations than are the vegetative cells. Food enzymes are more resistant to ionizing radiations than even the spores of bacteria. Very high radiation dosage required for inactivation of enzymes destroys food constituents and impairs safety of food. For these reasons, irradiation alone is not suitable for food stability. Hence, combination of processes is employed. Enzymes are more easily inactivated by heat, even blanching, and by certain chemicals. Low temperature, modified atmospheres, mild thermal treatment, vacuum packaging in combination with irradiation can ensure minimum changes in physicochemical, biochemical and sensory quality attributes and provide better quality products. Thank you.